Welcome to Lucid Mind Chemistry channel. In this video, I'll be solving Chemistry A-Levels multiple choice questions. Paper 11 from October-November 2022. For question timestamps and other useful information, please visit video description. Question number 1. Which sample contains the same number of the named species as the number of molecules in 35.5 grams of chlorine? First, we have to find out the number of molecules in 35.5 grams chlorine. Then we have to find out atoms in sulfur, in sodium, ions in potassium chloride, and molecules in CO2. Let's find out which one has similar number of particles as compared to 35.5 grams of chlorine. So first we can find out number of particles in chlorine. We can use formula. Number of particles is equal to moles of particles multiplied by Avogadro's constant. In this formula, the particles, it can mean molecules, atoms, ions. So let's suppose we have chlorine. Now chlorine exists in the form of molecules. It means number of particles will be number of molecules. So for chlorine, number of molecules is equal to moles of molecules. Now the formula for moles is mass in grams divided by molecular mass. Chlorine is Cl2. Atomic mass of 1 chlorine is 35.5, so into 2 it will be 71. So it is mass in grams divided by mR, 35.5 divided by molecular mass, which is 71, into Avogadro's constant. So number of molecules in chlorine, it is equal to 3 into 10 exponential 23. Let's see which one is similar to this. So we have atoms in 16 grams of sulfur. For this one we can use formula. Number of atoms is equal to moles of atoms into Avogadro's constant. Again, moles of atom is mass divided by molecular mass. Sulfur is 32. So 16 grams divided by 32.1 into Avogadro's constant. So it comes equal to 3 exponential 23 atoms. Now the value is similar, it means A could be correct answer. Second one is we have atoms in 23 grams of sodium, so we can use similar formula. Mass is 23, atomic mass of sodium is also 23. So it comes equal to 6.02 exponential 23 atoms. As this is more, so therefore it is wrong. Third one is ions in 74.5 grams of potassium chloride. Again, using formula, we have number of ions. It is equal to moles of ions. Now we have mass 74.5 grams. The molecular mass of this will be, we have potassium which is equal to 39.1. We have chlorine which is equal to 35.5. So the molecular mass, it is equal to 74.6. But we also know that 1 potassium chloride or 1 mole of KCl, it dissociates to form 1 mole of K positive and 1 mole of Cl negative. So it means 1 mole of KCl forms 2 moles of ions. So this much moles of KCl will produce 2 moles of ions. So we can multiply this one with 2, and then we have 6.02 into 10 to the power 23 from the formula. So total number of ions, which include potassium and chloride, both ions, it is equal to 1.20 into 10 is power 24. Last one is molecules in 88 grams of CO2. For moles, we have mass 88 divided by molecular mass of CO2. 1 carbon, 2 oxygen, it is 12 plus 32 equals 44. So this is also equal to 12.04 into 10 power 23 or 1.20 exponential 24. So therefore the number that is equal to the one given in chlorine, it is present in just A. Question number 2. Mixture R consists of 1 mole of C3H6 and 1 mole of C4H6. What is the minimum number of moles of oxygen molecules needed for complete combustion of mixture of R? We can write a balanced equation. We have C3H6 1 moles. We have C4H6 also equal to 1 mole, and they both combust in the presence of oxygen to form carbon will form CO2, hydrogen will form water. Let's balance this chemical equation. We can see we have 3 plus 4, 7 carbon atoms on the right hand side, so we can write 7 with CO2, 12 hydrogen atoms, so we can write 6 with H2O. Now we can find out number of oxygens. It is 14 plus 6, 20 on product side, so we can write 10 with O2. So it means 10 moles of oxygen molecules will be needed for complete combustion. Question 3. Which statement about the electrons in a ground state carbon atom is correct? Ground state carbon, atomic number of carbon is 6, its electronic configuration is 1s2, 2s2, and in 2p we have 2 electrons, out of which one is present in 2px, one is present in 2py. Now it says electrons are present in 4 different energy levels. In this one we only have 3 different energy levels, 1s, 2s and 2p, so therefore this is wrong. In part B it says there are more electrons in p orbitals than there are in s orbitals. In p orbitals we can see only 2 electrons are present, while in s orbitals 2 electrons each are present. So this is equal, it is not more. Part C, the occupied orbital of highest energy is spherical. Now this is the highest energy orbital which is occupied, it is p orbital, and p orbital is not spherical, it is dumbbell in shape. Part D, the occupied orbital of lowest energy is spherical. This is the one that is nearest to the nucleus, s orbital, and s orbital is always spherical in shape. So correct answer is therefore D. Question number 4. For the element sulfur, which pair of ionization energies has the largest difference between them? Now let's see sulfur. Sulfur belongs to 6th group of the periodic table, so it has 6 electrons in the outermost shell. Now what will happen? First we'll remove these 6 electrons, then 7th electron is going to be removed from the inner shell. So whenever there is a shell change, what happens? The inner shell, it is nearer to the nucleus, so the energy required to remove the 7th electron will be higher as compared to these 6 electrons. So there will be largest difference between 6th and 7th electron. So therefore it means we have difference between 6th and 7th ionization energy. Question number 5. How many sigma bonds are present in one given molecule? Let's draw the structure of this one. We have hydrogen attached to carbon, CH3 is attached to this carbon, then we have another CH, then we have CH3. This one is triple covalent bond, this one is double covalent bond. Okay, now let's find out the number of sigma bonds. All the bonds that are written in black, they are sigma covalent bonds, while the one in red are pi bonds. So we can count sigma bonds: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. So it is 30. Question number 6. Which molecule has an equal number of bonding electrons and lone pair of electrons? Now they are talking about the whole molecule, not the central atom. So let's find out the number of electrons by looking at the bonding. We have BH3, boron is in third group of the periodic table, so it has 3 electrons in the outermost shell. So all these 3 electrons are involved in bonding with 3 hydrogen atoms. So we have 3 pairs of bonding electrons or 6 bonding electrons, while there is no lone pair of electrons that is present. Lone pair of electrons means the one that is not involved in bonding. So A is wrong. B is CO2. Now we have carbon. It makes double covalent bond on both sides with oxygen. Oxygen belongs to 6 groups, so it has 6 electrons in total. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now we can see these show bond pairs, while the other ones are lone pairs. So there are 8 bonding electrons and there are 8 electrons present in the form of lone pairs. So both are equal, so answer could be B. Let's say in C we have 2 fluorine atoms attached with 1 oxygen. So oxygen is the central atom while fluorine are on the sides. Oxygen belongs to 6th group of the periodic table. It makes single covalent bond on each side. Fluorine is in 7th group, so it has 7 electrons in total. Now we can count, we can see that only 4 electrons are present in the form of bonds. So we have 4 bonding electrons and 16 lone pair electrons. So they are not equal. Last one is sulfur dioxide. Sulfur belongs to 6th group. It makes double covalent bond with oxygen on both sides. Oxygen is in 6th group. So there are 8 bonding electrons. Sulfur has 6 electrons as it belongs to 6th group of the periodic table. Now we can see we have 8 bonding electrons and 10 lone pair electrons. So correct answer is part B. Question 7. The table shows properties of 4 solids held together by different types of bonding. Which row correctly describes the properties of a solid with giant covalent structure? Now let's suppose we have some examples. We have diamond that has giant covalent structure. We have silicon dioxide which has giant covalent structure. So the melting point of giant covalent structure will be high. As we have extensive covalent bonding, so in order to melt this one, we need to break the bonds. Second is the solubility in polar solvents. Now diamond does not dissolve in polar solvents, so it is insoluble. So therefore giant covalent structures are insoluble. Correct answer is therefore A. Question number 8. The carbonate of an S-block element is reacted with an excess of hydrochloric acid. 0.833 grams of the carbonate releases 200 cm³ of gas measured under room conditions. What is the identity of metal carbonate? It could be sodium, potassium, which belong to first group. It could be magnesium or calcium that belongs to second group of the periodic table. Now they have given mass of the carbonate. So in order to find number of moles, we need to find out the molecular masses of all of them. Then we can use balanced equation. So sodium according to periodic table is 23. So 23 into 2 for sodium. We have 1 carbon which is 12, 3 oxygen which is 48. So molecular mass is 106. For potassium carbonate it is 2 into 39.1 for potassium. 12 and 48 which is 60 for carbon and oxygen. It is 138.2. For magnesium we have 24.3 plus carbon oxygen which makes 60. So it is 84.3. For calcium it is 40.1. So it is 100.1. Now let's find the number of moles for each of them. Moles is equal to mass in grams divided by molecular mass. So we have 0.833 divided by 106. So it is 0.0078 moles. Similarly for this one we have 0.833 divided by 138.2. It is 0.0060 moles. We can do it for third one. 0.833 grams divided by 84.3. It is 0.0098 moles. Then last one is calcium carbonate. So number of moles, it is equal to 0.0083 moles. Now as we have group 1 and group 2 compounds, so therefore we can write balanced equation. Let's suppose for group 1 it is metal 2, carbonate is 1. For group 2 it is metal 1, carbonate is also 1. So M2CO3 for group 1. When carbonate reacts with acid, it forms salt, water and releases CO2 gas. Salt is MCl, water is H2O, and then we have CO2 in the form of gas. Let's balance this equation. We have 2 metal moles, so we can write 2 with MCl. Now we can balance chlorine by writing 2. Then we have 2 hydrogen atoms and 1 carbon and 3 oxygens. So it is balanced now. From this one we can see 1 mole of metal carbonate, it produces 1 mole of CO2 gas. So number of moles is same. So let's see how many moles of CO2 is present in the question. In the question it says we have 200 cm³ of gas. So in order to convert this one into number of moles, we can use formula moles is equal to volume in centimeter cube divided by 24,000 centimeter cube. So number of moles of CO2, it comes equal to 8.33 exponential minus 3 moles, which is also 0.00833 moles. So in group 1 we can see we have sodium carbonate and potassium carbonate. Their moles are different as compared to this. From 1:1 ratio the moles should be same. Now let's write balanced equation for group 2 carbonates and then we can find out how many moles are produced. So for group 2 carbonate, it is metal carbonate MCO3 plus HCl. It forms MCl2 plus water plus CO2. Now balancing this one, we have 2 chlorine atoms, so we can write 2 with HCl. We have 2 hydrogens, oxygen is balanced, metal is balanced. So everything is balanced now, and we have 1:1 for gas and this carbonate. So it means same moles of carbonate should be present for same moles of gas. So as we have 0.00833 moles of gas, so same moles of carbonate should be present. It is not a magnesium carbonate, it is calcium carbonate, as it is 1:1 ratio. So therefore correct answer is then D. Question number 9. The enthalpy changes of formation delta HF of both PCl3 and PCl5 are exothermic. PCl3 reacts with chlorine. We have PCl3 in liquid form that reacts with chlorine gas to form PCl5 solid. Enthalpy change of this reaction is given as -124, which means that this is exothermic reaction. Which pairs of statement is correct? We have different statement. Enthalpy change of reaction is less negative than formation, is more negative than formation. Enthalpy change of reaction is less negative or more negative. Let's find out whether enthalpy change of reaction as compared to PCl5 formation is more or less negative. For this we can use Hess's law. This is the equation that is given. So I can rewrite this equation. I have PCl3 liquid plus Cl2 and it forms PCl5. Now the elements that make up these compounds are phosphorus, chlorine, and that's it. So now we can see phosphorus and chlorine, they can combine together to form these compounds, or they can combine to form these compounds. So on this side we can see we have enthalpy change of formation of PCl3 delta HF PCl3. And as chlorine, we can see chlorine is similar. We have chlorine gas as element as well as the reactant, so therefore there is no change or the change is 0. On this side we have PCl5 solid. So for this side we need enthalpy change of formation of PCl5. The enthalpy change of this reaction is given. It is -124 kilojoules per mole. So we can write delta HR equals -124. Now by Hess's law we can see these two steps combine together to give the energy of this step. So then we have enthalpy change of formation of PCl3 plus enthalpy change of reaction, and it is equal to this one, which is enthalpy change of formation of PCl5. Now let's see whether enthalpy change of reaction is less negative or more negative. We are talking about this one. As we know, this is negative because it is given in question. It is -124, so I can write that this part is negative. Enthalpy change of formation is also negative, so enthalpy change of formation of PCl5 is negative. For PCl3 it is also negative. So these two negatives, they combine to form this negative. It means that The value of this negative is larger, so we can say this is large negative, and the value of this negative is comparatively smaller, small negative, as these two combine to form this one. So we can see the enthalpy change of reaction is less negative as compared to enthalpy change of formation of PCl5. So this part will be correct, this part will be wrong. For other ones, we can see that it is less negative. So it is either A or C. Now let's look at the other part. We have statement 2, the Cl2 bond energy is needed in calculating enthalpy change of reaction. Now as we can see, chlorine is unchanged, so there is no need for finding out the energy change. So it is not needed. Correct answer is therefore C. Question number 10. A student mixes 25 centimeter cube of this much concentration of sodium hydroxide solution with same volume, same concentration of HCl. The temperature increases by 25 degrees centigrade. This is delta T. No heat is lost to the surroundings. The final mixture has specific heat capacity of 4.2 joules per centimeter per Kelvin. What is the molar enthalpy change for the reaction? Now we can use delta H formula. Delta H enthalpy change of reaction is equal to minus M, where M is the mass of solutions, C, which is the specific heat capacity, and delta T, which is change in temperature. Now delta T given here is in degree centigrade. The change in temperature, this is the temperature increase or delta T. You can change the unit without affecting the value. So we can write 2.5 Kelvin instead of 2.5 degrees centigrade. It is still correct. Now let's find out the total mass of solutions. We have 25 centimeter cube, which is equivalent to 25 grams, and 25 centimeter cube of second solution, which is equivalent to 25 grams. So in total we have 50 centimeter cube or 50 grams as mass. The value of specific heat capacity is 4.2 joules per centimeter per Kelvin. Change in temperature is in Kelvin 2.5. Now we can cut out the units, centimeter cube with centimeter, Kelvin with Kelvin, so the answer is in joules. This one, it is equal to minus 525 joules, delta H. Let's find out how much moles release this energy. So as we can see that volume and concentration is same, so we can use formula number of moles is equal to concentration into volume in decimeter cube. Concentration is 0.350 into volume is 25 centimeter cube, which can be converted to decimeter cube by dividing with 1000. So this will give us the number of moles that actually release this energy. So we have 0.00875 moles. So it means that this much energy is released by this much moles, 0.00875 moles. In the question, they are asking about the molar enthalpy change for the reaction. Molar enthalpy means the enthalpy change that is required for 1 mole of a substance. Now for this much moles, we do have the energy value. For 1 mole, we can cross multiply and find the value. So for 1 mole of substance, it will be equal to X. We can cross multiply. So then X will be equal to minus 525 into 1 divided by 0.00875. So it is equal to minus 60,000 joules. Or we can also convert it into kilojoules as based on this answer. So we can divide it with 1000 to give, it will give us minus 60 kilojoules per mole, as it is for 1 mole of a substance. So correct answer is therefore B. Question 11. Ammonium ions are converted into nitrate ions by bacteria. What is the change in oxidation number of nitrogen? Let's find out the oxidation states of nitrogen in ammonium and nitrate. The formula of ammonium is NH4 plus 1. The formula of nitrate is NO3 minus 1. So we have one nitrogen, we have 4 hydrogen atoms, we have total charge which is equal to plus 1, we have one nitrogen, 3 oxygen atoms, total charge is negative 1. So nitrogen plus 4, because one hydrogen is plus 1, equals plus 1, nitrogen equals minus 3. In this one, oxygen is minus 2, we have 3 oxygen, so it will be minus 6, or nitrogen is plus 5. So now for change, we can see what can we add into negative 3 to make plus 5. So we can definitely add plus 8. If we add plus 8 into negative 3, the answer will be plus 5. So the change in oxidation number is then plus 8, which is C. Question 12. Sodium dichromate 6 Na2Cr2O7. It reacts with hydrogen peroxide H2O2, producing Cr3 plus ions, water and oxygen. What is the correctly balanced ionic equation for this reaction? Now in ionic equation, first we have to find out the equation that has equal number of atoms on reactant and product side, and the charges must also be balanced. So let's see in part A. We have Cr2. Let's start from chromium. 2 chromium on the reactant side, 2 chromium on the product side, so chromium is balanced. 7 oxygen atoms, 2, and in total we have 9 oxygen atoms on reactant side. Now on product side we have 2 and 8, which is 10. So oxygen is not balanced. In part B we have 2 chromium, chromium is balanced. We have 7 oxygen atoms and 3 into 2 is 6, so 7 plus 6 becomes 13. 13 oxygens are on reactant side. We have 7 in water and 6 in 3O2, so 13 on the product side. So oxygen is also balanced. Then we have 8 hydrogen atoms and 6, 8 and 6 becomes 14, and 7 into 2 is 14. So hydrogen is also balanced. Then we have 2 oxygens. Oxygen is already balanced. So we can see number of atoms is same. Now let's look on the charges. So Cr2O7, the whole charge is negative 2. We have 8 hydrogen H plus, so there is plus 8 charge in total. And on the product side we have 2 Cr3 plus, which makes it plus 6. And we do not have charges on these. So plus 8 minus 2 becomes plus 6. So on the reactant side and on the product side the charges are balanced. So B could be correct option. Let's see part C. We have Cr2O7, 2 chromium balanced. 7 and 12, it is 19 oxygen on the reactant side. 10 and 12, it is 22 on the product side. So oxygen is not balanced. Part D, 2 chromium, 7 and 6, 13 oxygens. We have 7 and 6, 13 oxygen. So oxygen is also balanced. There are 14 hydrogen plus 6, 20 hydrogen atoms. We only have 14 on the product side. So the only balanced ionic equation is part B. Question 13. In which equilibrium reaction is the position of equilibrium moved to the right hand side by increasing the temperature and also by decreasing the pressure? Let's look into the given equations. First and second one, they are positive, so they are endothermic. Third and fourth are exothermic. So let's see first the effect of temperature. So by increasing temperature, endothermic reaction always moves in forward direction, and exothermic reaction moves in backward direction. So the equilibrium shifts to the back for C and D, and equilibrium shifts in forward direction for A and B. Now it says in which the position of equilibrium moves to the right hand side. So it should either be A or it can be B. Now let's see what is the effect of pressure. Increasing pressure moves equilibrium from more number of moles of gases to less number of moles. But in this one we have decreasing in pressure, so it will move from less number of moles to more number of moles for gases. Let's see how many moles are there. We have 1 mole of hydrogen, 1 mole of CO2, so in total 2 moles are there. In product again we have 2 moles. So whenever there are same number of moles on either side of the reaction, the equilibrium position does not change by pressure. So one is incorrect. Second one, we can see we have 1 mole on reactant side and 2 moles on product side. So by decreasing pressure, the equilibrium will move from less number of moles to more number of moles for gases. So yes, the equilibrium will move in forward direction, which is needed. So correct answer is then B. Question 14. Ethanol is produced industrially by reacting ethene and steam. We have this chemical reaction that is given. Kp has a value of 1.8 exponential minus 5, and partial pressures are given. For ethene we have 4.8 exponential 3. For steam we have this much, and the unit is kilopascals. Which row is correct? First we have to find out the partial pressure of ethanol at equilibrium in kilopascals, and second thing is the units of Kp. Okay, so let's start. We can write Kp for this reaction. Kp is the partial pressure of product, which is C2H5OH, divided by the partial pressure of the reactants. We have pressure of C2H4 multiplied by pressure of H2O. So value of Kp is given, ethene and steam is also given, so we can find out this one. Let's rearrange the equation. Now we have partial pressure of ethanol C2H5OH. It's equal to Kp into partial pressure of C2H4 into partial pressure of water. Let's put values. Kp is 1.8 exponential minus 5. Pressure of C2H4 is 4.8 exponential 3. For water it is 2.8 exponential 3. Now the value, it comes equal to 2.42 into 10 to the power 2. Let's look on the units of this partial pressure. We have kilopascals as the unit. So we have to find out the units of Kp, not the unit of this one. So for Kp, as we know, we have one reactant on top and 2 reactants at bottom. So it will be kilopascals for this one, kilopascals for this one, as it is raised to the power 1, kilopascals for this one. Now these two, they are cancelled out, and when this goes above, it will become per kilopascals. So correct answer seems to be A. Question 15. A large excess of magnesium ribbon is added to dilute hydrochloric acid, and the volume of hydrogen gas produced is measured as the reaction proceeds. The reaction is exothermic. Results are shown. We have total volume in centimeter cube on y-axis, we have time on x-axis, and this is the graph. Which row explains the changes in the rate of reaction between points P and Q and between points Q and R? Now we can see between P and Q the rate of reaction it is increasing as the graph it becomes more steep, while in Q and R the rate of reaction is slowly decreasing as the graph becomes less steep. So let's see. Between points P and Q the reaction temperature is increasing, magnesium surface area is decreasing. So we have two options. Let's see, in the question it says we have large excess of magnesium ribbon. So when something is in excess, then it does not decrease. So the surface area is decreasing, this one is wrong. Now we can see as acid and metal reacts, the reaction is exothermic. So when the reaction is exothermic, heat is released. Now this heat, it also provides kinetic energy to the reactant particles. So the reaction temperature is increasing, therefore the rate of reaction also increases. So this could be correct option. Then we have between points Q and R, the acid concentration is falling, that's why the rate of reaction decreases, or the magnesium has been used up. So we have again two options. Again we can see magnesium is in excess, so it is not used up. So the other point could be true. Because acid is not in excess, so therefore the acid concentration will decrease with time, so the rate of reaction will become slow. Correct answer is therefore A. Question 16. Measurements are made to determine the activation energy of a reaction. The diagram shows EA on the Boltzmann distribution at temperature T1. On y-axis we have number of molecules as is with Boltzmann distribution graph, and on x-axis we have energy. This is the activation energy of the reaction for molecules. Measurements are then made at higher temperature T2, which diagram correctly shows the Boltzmann distribution and EA at T2. So always remember, whenever temperature is increased, this peak it moves in forward direction and it reduces in size. When temperature is decreased, it moves in backward direction and size of this peak is increased. So in this one we are making higher temperature, so it means we are moving in forward and downwards. So at high temperature the peak should be in forward direction and it should be less in height. So let's see which one shows that. In C and D we can see there is no change in peak, so C and D are wrong. While in A and B we can see the peak has shifted in forward direction and size has also decreased. So it could be A or B. Let's look on the activation energy. So the temperature does not change the activation energy of any reaction. Activation energy can only be changed by catalyst. So activation energy should stay at its place. We have this much activation energy. While in this one we can see activation energy has been reduced. So B is wrong because activation energy should not be disturbed. Correct answer is therefore A. Question number 17. The electrical conductivities of two compounds Y and Z are shown. We have for Y and for Z, what are compounds Y and Z? We have to identify whether Y is aluminum oxide or sodium chloride and Z is silicon chloride or aluminum oxide. So first let's look for Y. It says conductivity of the compound in liquid state. It is good. Aluminum oxide has ionic bonding, so therefore ionic bonds are good conductors in liquid state, so it could be Al2O3. NaCl is also ionic compound, so it is also good conductor in liquid state, so it could be NaCl. Second thing is we can see for Y the conductivity of mixture obtained by adding the compound to water. It means the compound is soluble as it is good conductor. So among these two, aluminum oxide is not soluble while sodium chloride is soluble. So only NaCl. NaCl, when dissolved in water, it converts to ions, and those ions, they basically conduct electricity. Now we can see for Z, we have again two options, aluminum oxide and silicon chloride, SiCl4. So let's see, it says does not conduct in liquid state. SiCl4 is covalent compound. It is bad conductor in liquid state. So it means this one is SiCl4. Let's see, aluminum oxide, it is good conductor in liquid state, so therefore this one is wrong. Silicon chloride can be correct. Second option, conductivity of the mixture obtained by adding the compound to water. Now aluminum oxide does not dissolve in water, so we can cross this one out. While silicon chloride, we know that when we add silicon chloride to water, what happens is that SiCl4, it reacts with water and forms SiO2 solid along with HCl. Now HCl is acidic and HCl can form ions, and then it will become good conductor in solution form. So SiCl4 is the one that is correct. So overall correct answer is therefore C. Question 18. Which row describes the relative sizes of the ionic radii of sodium positive, magnesium 2 positive, sulfur 2 negative? Let's look at the atomic number and the number of electrons present in number of shells. Sodium is 11, magnesium is 12, sulfur is 16. Now let's find the number of electrons present in this ion. So sodium is 11 plus 1 means 1 electron is lost. So now we have 10 electrons. In magnesium 2 electrons are lost, so again we have 10 electrons. In sulfur we can see we have -2 charge, so it means 2 electrons are added, so 16 plus 2 becomes 18. Now we can do the shell configuration for sodium positive. It is first shell contains 2 electrons, second one contains 8 electrons. In total we have 10. Same is for magnesium 2 and 8, as total is 10. But for sulfur we have 3 shells. 2 in the first, 8 in second, 8 in the third one. So it means we have larger shells, so this should be the largest one. So we can have S2 minus, S2 minus, so it is either A or B. Now let's look among these two. We have equal number of shells, we have same number of electrons in equal number of shells, but number of protons is different. For this one we have 11 protons, for this one we have 12 protons. So now 12 protons are attracting 10 electrons, in this one 11 protons are attracting 10 electrons. So more attraction will be for this one. You should remember this point, that whenever number of shells and number of electrons are same, so the size depends on the number of protons. More number of protons means smaller size. So magnesium 2 plus has smaller size as compared to Na plus 1. So smallest should be Mg2 plus, then we have Na plus. Correct answer is therefore B. Question 19. The oxides barium oxide, calcium oxide, magnesium oxide and strontium oxide all are group 2 elements, so they all produce alkaline solutions when added to water. Which oxide produces the saturated solution with the highest pH? Now highest pH means we have more OH negative ions. Now these are group 2 oxides, and for group 2 oxides you should remember solubility increases down the group. Now the one which is at bottom will be the most soluble, as we know barium is at the bottom of group 2 in comparison with these 4, so therefore barium oxide will be most soluble. It will form barium hydroxide, aqueous. Aqueous means there will be ions, Ba2 positive and 2 moles of OH negative. So due to the presence of OH negative, we have the highest pH. So therefore correct answer should be barium oxide. Question 20, which row is correct? First thing is the temperature that is needed to decompose group 2 metal nitrates. Second thing is the solubility of group 2 sulfates. Now metal nitrates means the compounds that contains NO3 negative ions. So in group 2, carbonates as well as nitrates. Whenever you move down in group, stability increases. So the compounds become more thermally stable. It means the one that is at the bottom, it will require more heat energy to decompose. So the temperature needed to decompose, it will definitely increase down the group. It is not going to decrease. Second thing is the solubility of group 2 sulfates. For this one, you should remember that group 2 sulfates, they become less soluble down the group. As barium is at the bottom, so barium sulfate is solid. It is almost insoluble. So the solubility, it decreases down the group. Correct answer is therefore D. Question 21, which statement about group 17 elements and compounds is correct? Group 17 are halogens. Let's see. Part A, it says sodium chloride produces chlorine when reacted with concentrated sulfuric acid. Now you can remember the reaction for this one. NaCl, it reacts with sulfuric acid, which is concentrated. It will form sodium hydrogen sulfate, NaHSO4, along with HCl. Now HCl does not react further with sulfuric acid. So HCl is not converted to chlorine. Part A is wrong. Part B, sodium chloride produces chlorine when reacted with bromine. Let's react sodium chloride with bromine. NaCl plus Br2. Now we know in halogens we have fluorine, then chlorine, then bromine, then iodine. The reactivity decreases as we move down the group. So it means the one that is bottom, it cannot replace the one which is on top. So bromine cannot replace chlorine. So this reaction cannot occur. Chlorine is not formed. Part C, now we have sodium bromide produces bromine when reacted with concentrated sulfuric acid. So let's do the reaction. We have NaBr plus concentrated sulfuric acid, H2SO4. Now this will make similar product as this one, NaHSO4, along with the production of HBr. But now HBr can further react with sulfuric acid. So HBr plus sulfuric acid, it will form Br2, SO2 and H2O. So from HBr, that Br2 is formed. So sodium bromide does produce bromine when reacted with concentrated sulfuric acid. So C should be the correct answer. Part D, sodium bromide produces bromine when reacted with iodine. Now we can see iodine is below bromine in reactivity series. So therefore iodine cannot replace bromine. So sodium bromide will not produce bromine when reacted with iodine. Correct answer is therefore C. Question 22. Chlorine is bubbled through 100 cm³ of hot 4 mole per decimeter cube sodium hydroxide until the reaction is complete. This is the equation that is given. Which row is correct? First, we have to find out the value of X. We do not have Y, we do not have Z. Then we have to find out the concentration of sodium aqueous after reaction in mole per decimeter cube. So let's start with balancing first. Now we can see we have 6 sodium atoms on the reactant side, and on product side we have sodium distributed in 2 compounds, so therefore we cannot balance because we do not know the ratio. Then we have 6 oxygen atoms. Oxygen atoms is 6. 3 are given in water. So it means this oxygen, it must be 3 in order to make it 6. So for this to be 3, Z should be equal to 1. Now we have the value for sodium. If Z is 1, then it is 1 sodium atom. So in total we had 6. So out of which 1 is here. So then 5 should be here. So it means Y is 5. If we have 5 NaCl and 1 NaClO3, it means total number of chlorine atom is 5 in this and 1 in this. So in total we have 6 chlorine atoms on the product. So we can write 3 with X. So X should be 3. So now balancing, we have 6 moles of NaOH that react with 3 moles of Cl2 to form 5 moles of NaCl, 1 mole of NaClO3 and 3 moles of water. So X is 3. Second thing is the concentration of Na positive aqueous after reaction. We can see we have 6 moles of Na positive ions on reactant side. On product side again we have 5 and 1, 6 moles of Na positive aqueous. But we can also see 3 moles of water are produced after the reaction. So it means water is being produced in this reaction. So what will happen? The volume will increase. Initially the volume of water was 100 centimeter cube. Now it will become more as more water is being produced. And as we know, concentration is equal to number of moles divided by volume in decimeter cube. So by increasing volume, the concentration should decrease. So initially it was 4, now it should be less than 4. Correct answer is therefore B. Question 23. Which statement about ammonia or the ammonium ion is correct? Part A. Ammonia gas is produced when an aqueous solution containing the ammonium ion is reacted with a strong acid. Now this is incorrect because ammonium salt when reacts with base, it forms salt water and releases ammonia gas. So it should be base. Part B. Silver iodide is soluble in concentrated aqueous solution of ammonia. Now silver iodide is insoluble in concentrated aqueous solution of ammonia. Silver chloride and silver bromide, they are soluble. Part C. The ammonium ion has the same number of electrons as methane molecule. Let's find out this one. Ammonium ion is NH4. We have positive charge. Methane is CH4. Atomic number of nitrogen is 7, so we have 7 electrons in nitrogen. Atomic number of hydrogen is 1, so we have 4 electrons in 4 hydrogen atoms. Overall charge is plus, it means 1 electron is less. So 7 plus 4 should be 11, but it is 10 electrons in total. In methane, atomic number of carbon is 6, so we have 6 protons or electrons. Atomic number of hydrogen is 1, so we have 4 electrons. So in total again we have 10 electrons. So number of electrons is same. This could be correct. Part D. The square planar ammonium ion contains a dative covalent bond. Let's look at the structure of ammonium ion. We have nitrogen. It is bonded to 3 hydrogen atom. In the lone pair of nitrogen, it is given to H positive. So there is a dative covalent bond and there are 3 other covalent bonds. So in total we have 4 bonds around central atom. So 4 bonds makes this structure tetrahedral. It is not square planar. Correct answer is therefore C. Question 24. Sulfur dioxide can be catalytically oxidized by an oxide of nitrogen in the atmosphere. Which reaction shows how the catalyst is reformed? Let's look at the reaction. In atmosphere, what happens? SO2, it reacts with NO2, nitrogen dioxide, and SO2 oxidizes to SO3. While NO2 is itself reduced, it forms NO. Now this NO2, it is reformed because this NO in atmosphere, it can react with oxygen to form NO2 again. So we can see that NO2 was the reactant and now it is regenerated. So it means it is behaving as a catalyst because it can again oxidize another SO2 molecule. So this part is oxidation, SO2 to SO3, and NO2 is the catalyst which is reformed. So this is the equation for reformation of catalyst. So correct answer should be D. Question 25. Separate 1 gram samples of sodium oxide, magnesium oxide, aluminum oxide, silicon dioxide. So these are period 3 oxides. Sodium chloride, magnesium chloride, aluminum chloride, silicon chloride. These are period 3 chlorides. They are added to separate beakers containing water and stirred. The number of beakers containing a white solid is Q. Now first is the solubility of these compounds in water. You have to find out the compound that is insoluble or makes a precipitate. An excess of sodium hydroxide aqueous is then added to each beaker and stirred. The number of beakers now containing white solid is R. You have to find out how many Q's are there and how many R's are there. First one is sodium oxide. Sodium oxide can dissolve in water to form sodium hydroxide aqueous. So it will not form any precipitate. Second one is magnesium oxide. The solubility of magnesium oxide is less. It is the least soluble oxide in group 2. So we do have white precipitate as it is partially soluble. Third one is aluminum oxide. Aluminum oxide does not dissolve in water. Then we have silicon dioxide. Silicon dioxide is also insoluble in water. Then we have sodium chloride, which is highly soluble, so it forms NaCl aqueous. Magnesium chloride is also ionic compound. It will dissolve to form magnesium chloride aqueous solution. Al2Cl6. This one is aluminum chloride. So aluminum chloride dissolves in water to form HCl and aqueous compound. It forms Al H2O5 OH and H plus. Both are aqueous. Then we have SiCl4, silicon chloride. It can react with water to form silicon dioxide and HCl. Silicon dioxide is insoluble. So now we can see that in total we have 1, 2, 3 and 4. So 4 white precipitates are present with water. So it could be C or D. Now let's see which one forms white precipitate with sodium hydroxide among these solutions. So sodium hydroxide and sodium hydroxide, it is the same. It will not form any precipitate. Magnesium hydroxide is still in the form of precipitate, as magnesium and hydroxide, it is insoluble, partially insoluble. Third one is aluminum oxide, Al2O3. Now aluminum oxide is soluble in sodium hydroxide. It will form NaAlOH4. So we only have one precipitate so far. Then we have silicon dioxide. Silicon dioxide is soluble in hot concentrated alkali, but we just have sodium hydroxide aqueous, so therefore it will still be in the form of precipitate. So now we have 2. Then we have sodium chloride. It is not forming any precipitate. Now we have magnesium chloride. Magnesium hydroxide is formed, which will be precipitate, as was the case in this one. So now we have 3. Then we can move towards Al2Cl6. Al2Cl6 is soluble in sodium hydroxide aqueous, as it formed this acidic solution, and this acidic solution is then neutralized with sodium hydroxide. Then we have SiCl4. SiCl4 can react with sodium hydroxide to form SiO2, which is insoluble solid. So now we have 4 precipitates with sodium hydroxide aqueous. So therefore correct answer should be D. Question number 26. Which pair of alcohols are isomers of each other? Now isomers means those compounds that have same molecular formula but different structures. Let's see, part A, we have butane 1-ol and 2,2-dimethylpropane 1-ol. We can draw structures. In butane we have 4 carbon atoms. One ol means that OH is present on the first carbon atom. Now we can draw for 2,2-dimethylpropane 1-ol. As we have propane, it means there are 3 carbon atoms. Now we have 2 methyl groups attached on second carbon, and on first carbon it is alcohol. So again alcohol on first carbon. On second carbon we have 2,2-dimethyl. So 2 methyl groups are attached. Now we can count number of carbons first. So we have 4 carbons in total. In this one we have 5 carbons. So we have different formulas. So A is wrong. Part B, butane 2-ol and 2-methylpropane 2-ol. Now butane 2-ol means we have 4 carbon atoms. 2-ol OH is on second carbon. 2-methylpropane 2-ol. So we have propane. Propane has 3 carbon atoms. On second carbon we have methyl group, and on second carbon we have alcohol. So it is CH3 and OH. Now we can compare these two. We can see we have 4 carbon atoms here. In total we have 4 carbon atoms in this one too. So let's find out, or let's draw the number of hydrogen atoms, then we can count whether they are same or different. So CH3, CH, CH2, CH3. CH3, CH3. Each carbon is making 4 single covalent bonds. We have 10 hydrogen atoms, 1 oxygen atom. We have 10 hydrogen atoms, 1 oxygen atom. So B seems to be correct because molecular formula is same, only the structures are different. Then we have pentane 1-ol, and this one is same compound, so we can compare this one with pentane 1-ol. So in pentane we have 5 carbons. 1-ol means OH is on first carbon, so again this has more carbon atoms as compared to this one. It has 4, this one has 5. So this is wrong. Then we have propane 2-ol and 2-methylpropane 2-ol. So in propane 2-ol we have 3 carbon atoms, and alcohol is on second carbon. So in total we have 3 carbons, while in this one we have 4 carbons. So correct option is B. Question number 27. How many chiral carbon atoms are there in one molecule of 2,2,4,5 tetramethylhexane 3-ol? Now chiral carbon means those carbon that have 4 different groups or 4 different elements attached with it. Let's draw a structure. We have hexane. Hexane means that in total we have 6 carbon atoms. Tetramethyl and 3-ol. First let's draw 3-ol. 3-ol means that on third carbon atom we have alcohol functional group. So this is OH. Now tetra means 4, methyl is CH3, so we have 4 CH3 on these carbon atoms. So 2 on second carbon, 1 on fourth, and 1 is on fifth carbon. Now rest of the number of hydrogen atoms. Let's see, the first carbon is this one. It has 2 similar atoms, so it is not chiral. Second carbon, it has got 2 same groups, so it is not chiral. Third carbon, it has 1 OH, 1 hydrogen, 1 left side, which is different as compared to the right side. So this one is chiral. Then looking at this carbon, we can see we have a hydrogen atom, CH3 group, and right side is different as compared to left side. So this is also chiral. Then moving to this carbon, we can see with this carbon we have 2 same groups attached, so it is not chiral. And last carbon is CH3 having 2 hydrogen atoms, so it is also not chiral. So we only have 2 carbon atoms that are chiral in this compound. So answer is B. Question 28. Which pair of reagents react together in a redox reaction? Now redox reaction is the one in which both reduction and oxidation takes place. Let's see. First one is CH3, CH, CH2, as number of hydrogen is less, so it means it is an alkene reacting with bromine. So now we can react it. We have CH3, CH, double bond CH2 plus Br2. Now bromine is added to those carbon atoms that make double bond, and double bond is then converted to single covalent bond. So the product is like this. We have CH3, CH, CH2. One bromine goes to first carbon, one goes to second carbon that are involved in double bond. Now let's see whether this one is a redox or not. On the reactant side, we had bromine molecule. The oxidation state of molecule is 0. On product side, now it is attached to carbon atom, so it is -1. So 0 to -1 is reduction. So for bromine reduction takes place. For carbon, we can see it goes from 0 to +1, as it is now attached to electronegative element, so therefore the oxidation state is positive. So for carbon, it is oxidation. So A could be correct answer. Part B, we have alcohol and concentrated phosphoric acid. Now concentrated phosphoric acid, it can react like concentrated sulfuric acid, and elimination occurs in which water molecule is removed. So let's draw the structure. We have CH3, CH2, CH2, OH. Now from one carbon atom, OH is removed, while from adjacent carbon, a hydrogen atom will be removed. So an alkene will be formed. Product is like this. We have CH3, CH, double bond CH2, along with the formation of water molecule. Now we can say oxidation state of oxygen was -2 on the reactant side. It is still -2 in water. Hydrogen was +1. It is still +1. In halogenalkene, the oxidation state does not change. So B is wrong. Let's see, we have part C, in which we have ketone, propanone plus HCN. Now this one will undergo addition reaction. CH3, C double bond O, CH3 plus HCl. Now the product formed is CH3 COH CN CH3. Hydrogen is +1, Cn is -1, it is still -1. Hydrogen is +1, oxygen was -2, now it is -2. So no changes, so therefore it is also wrong. Last one is we have ester and dilute sulfuric acid. So HC double bond O C2H5. In the presence of acid, ester breaks to form carboxylic acid and alcohol. So we can see there is no change in oxidation state of oxygen, hydrogen. It is -2, it is -2 in water, it is +1, it is still +1 in water. C2H5OH. So overall there is no change in oxidation state, so this one is also incorrect. Correct answer is therefore A. Question 29. The structure of centonin is shown. This is the structure of centonin. Centonin is first reacted with warm dilute sulfuric acid. The product of this reaction is treated with cold dilute acidified KMnO4. Then we have final product Q. How many atoms of hydrogen in each molecule of Q will react with sodium metal? So basically there are three reactions. Let's go through them one by one. First one is, it says it is treated with warm dilute sulfuric acid. Now let's look at the functional groups. We have alkene, we have a ketone, again an alkene and an ester functional group. So in the presence of warm dilute sulfuric acid, what happens? The ester, it breaks. The carbonyl part becomes a carboxylic acid, while the O oxygen part, it becomes an alcohol. And then second reaction, it says it is treated with cold dilute acidified KMnO4. Now this one, it changes alkenes to diol. So whenever we have double bonded carbon, it is changed to single bonded carbon along with OH groups on each carbon. So let's do both of these reactions. We can draw the structure. Ketone is not affected. Oxygen, it changes to carboxylic acid, alcohol. While the other part, carbonyl part, it changes to carboxylic acid. Now alkenes are also converted to alcohols. So this is the product for first two reactions. Now we have product Q. This one is Q. It says how many atoms of hydrogen in each molecule of Q will react with sodium metal. Now let's see, when sodium metal, it reacts with alcohol or carboxylic acid, it forms alkoxide. So whenever it is OH, it will form O negative and A positive along with the loss of hydrogen atom. So this one, it will become O negative and A positive, O negative and A positive. So we can say 1, 2, 3, 4, 5, 6 atoms of hydrogen are replaced. So therefore answer is 6. Question 30. Compound R can be formed from 1-bromopropane, which is halogenoalkane, using nucleophilic substitution reaction followed by an oxidation reaction. So we have two reactions. One is nucleophilic substitution, in which bromine is substituted with something else. Then we have an oxidation reaction and we have to make compound R. What is the identity of R? So we have different compounds that are given. Let's see if we can make propanoic acid. So for propanoic acid, we can start with this one. We have 1-bromopropane, 3 carbons in propane, and on first carbon we have bromine. First is nucleophilic substitution. So in order to convert this part into carboxylic acid, we need to replace it with OH. So nucleophilic substitution can occur in the presence of aqueous alkali. This Br, it is now changed to OH. And now we can oxidize this one. As it is primary alcohol, 3-carbon primary alcohol, so it will form 3-carbon carboxylic acid. So yes, propanoic acid can be formed by these two reactions. Second one is propanone. Propanone is a ketone that has 3 carbon atoms. So product should be like this. In order to make ketone, we need secondary alcohol, not primary alcohol. Secondary alcohol is the one in which OH is on second carbon atom. But in the reactant, we had bromine on first carbon, so we can add OH on first carbon only because OH is replacing bromine. It cannot add on second carbon, so therefore this is wrong. Third one is propylamine. Let's see if we can make propylamine. So again, starting with 3-carbon bromine, bromopropane. If we add ammonia in excess, we can replace bromine with NH2. So this is propylamine. It is already formed, but still we have to do oxidation. So if we do oxidation of this, then it will make something else like oximes, which are out of our syllabus. So therefore propylamine cannot be formed using these two reactions. Last one is propyl ethanoate. This one is ester. So we have 2 carbons on one side as it is ethanoate. We have 3 carbons on other side as it is propyl. So for propyl ethanoate, we need 2 compounds. One is 3-carbon alcohol, which can be formed from this one, as we have made 3-carbon alcohol from this bromopropane. But we also need 2-carbon carboxylic acid. Now 2-carbon carboxylic acid cannot be formed in these reactions, so therefore this is wrong. Correct answer is therefore A. Question number 31. 3 colorless liquids with the following formula are contained in separate unlabeled bottles. So we have carboxylic acid, we have secondary alcohol and carboxylic acid, we have a ketone and carboxylic acid. Which 2 tests carried out on separate samples of each liquid will successfully identify each liquid? So we have to separate these 3 based on these tests. Let's see, first test is sodium hydrogen carbonate. Now sodium hydrogen carbonate, it can react with acid to form carbon dioxide gas, fizzing. So therefore carboxylic acid can be identified. Now if this one is compound 1, this is 2, this is 3, then test 1 sodium hydrogen carbonate is positive for all of 3, for 1, 2, 3, because all of them contain carboxylic acid. So we cannot differentiate between these 3, as all 3 will give the same observation. Now we have part C, warm acidified dichromate. This one, it behaves as oxidizing agent. Now carboxylic acid, it cannot be oxidized further, and neither is ketone. So we only have secondary alcohol that can be oxidized further to ketone. So 2 will react, 2 will give a positive result with this one. 1 and 3 is unreacted. Now let's move to test 2. In test 2 we have 2,4-D-NPH. Now 2,4-D-NPH, it can be used to identify aldehyde and ketones only. Second one is Tollens reagent. Tollens reagent can be used to identify aldehydes only. So now let's see with 2,4-D-NPH, 2 is already done. So now 2,4-D-NPH, it does not react with 2 because we neither have aldehyde nor ketone. It does not react with 1 because we have carboxylic acid. It can only give positive result with 3. So this one will give positive result with 3 only. 1 is unreacted. So all 3 can be separated based on this test. Now second one is Tollens reagent. Tollens reagent, it can only react with aldehyde, and aldehyde is absent in all these 3. So it will not give any result. So only 2 can be identified using D, while all 3 can be identified using C. Question number 32. An alcohol X reacts with a dicarboxylic acid Y to form a double ester Z. The diagram shows the structure of the ester. We have C double bond O functional group. This is ester. Which row about the reactants forming ester Z is correct? We have to find out the class of alcohol, the shape of the ring in Y. Now ester, it can be formed by 2 starting materials. We must have a carboxylic acid. We also need an alcohol. So by breaking carbon-oxygen bond in ester, we can find out the reactants. So the part that contains oxygen, it comes from alcohol, and now these two are identical, so we can find out the alcohol. It contains 3 carbons and an OH group. So we have CH3, CH, OH, CH3. And this one we can see the carbon attached with OH is directly attached to 2 other carbon atoms, so it is secondary alcohol. It is not tertiary. The shape of ring in Y. Now let's see this part, it is X as it is an alcohol. Dicarboxylic acid would be Y. So now the carbonyl part, it comes from carboxylic acid, as it is di means 2 carboxylic acids are there. So we have this reactant, C double bond O, OH on one side, C double bond O, OH on other side. Now we can see the ring, it contains carbon and hydrogen only. Each carbon is making 4 covalent bonds. So we have 2 hydrogens on this carbon and 1 hydrogen on this carbon. Now carbon makes tetrahedral structure whenever it is making 4 covalent bonds. So each carbon is tetrahedral and bond angle is 109. So now we can see as the structure is tetrahedral, it means the carbons must be twisted. They are not present on the same plane because of tetrahedral structure, so it is non-planar. Correct answer is therefore A. Question number 33. W reacts with alkaline iodine aqueous to form a yellow precipitate and CH3, CH2, CO2 negative ions. So it is propanoate ions. Which row identifies W and the yellow precipitate? So we have butanone, which is 4 carbon ketone. We have propanone, which is 3 carbon ketone. Let's see how do they react with alkaline aqueous iodine. Butanone contains 4 carbon atoms, 1, 2, 3, 4. As it is ketone, so central carbon must be attached with oxygen. Now first reaction is with iodine, aqueous, alkaline, and the carbon that is present with C double bond O, it will react with halogen. We have 3 hydrogens, 2 hydrogens, 3 hydrogens. Now product will be C, C, C double bond O, and with this carbon now we have 3 iodine attached. 3 hydrogen atoms are replaced. Now in second step we have sodium hydroxide and hydrolysis takes place. So this C double bond O and this carbon bond, it breaks. The product is like this. We have 3 carbon, CH3, CH2, C double bond O, and this will become O negative and A positive. So we have sodium propanoate ion that is formed, and this carbon Ci3, it goes with NaOH upon hydrolysis to form CHI3. This is yellow precipitate. So CHI3 is the yellow precipitate, it is not the other one. Now let's see, with butanone we can see we have 3 carbon propanoate ion that is formed, CH3, CH2, C double bond O, O negative. So this part can be correct. Let's see what happens with propanone. So if we have 3 carbon atoms, propanone, again in first step halogenation will occur and the product will be CH3, C double bond O, and this CH3 that is directly attached to carbonyl carbon, it will become CI3. In second step we have sodium hydroxide, hydrolysis will take place. So now we have 2 carbon sodium ethanoate ion that is formed. So it is CH3, C double bond O, O negative and A positive, along with the yellow precipitate which is CHI3. So propanoate ion should be formed while it is ethanoate ion. So therefore this is wrong. Correct answer is butanone. Question 34. Ethanol reacts with hydrogen cyanide in the presence of potassium cyanide to produce hydroxynitrile. What is the first step in the mechanism of this reaction? Now KCN, it produces K positive and Cn negative ions. In Cn negative, lone pair of electron is present on carbon atom. This carbon will attack partial positive carbon of carbonyl carbon. So the arrow is always from this lone pair to partial positive carbon. It is incorrect in the first one. This one seems correct, as this lone pair, it will attack this carbon and this electron, it will shift to oxygen. In this one the lone pair is on nitrogen, which is wrong because lone pair is on carbon atom. In part D we have again the double bond is attacking H positive, which is incorrect. We can also clarify this one, whether double bond is on carbon or on nitrogen. Let's suppose we have HCN. In HCN the carbon atom makes 3 bonds with 1 nitrogen, triple covalent bond, and single bond with 1 hydrogen atom. So when heterolytic bond fission occurs, this hydrogen, it loses electrons, so it becomes positive, and this lone pair goes to this carbon, so Cn becomes negative. That's why lone pair is on carbon, it is not on nitrogen. So correct answer should be part B for the mechanism. Question 35. Structural isomerism and stereoisomerism should be considered when answering this question. How many isomeric compounds with molecular formula C5H6O4 contain 2 carboxylic acid groups and 1 double bond? Let's see, we have 5 carbon, 6 hydrogens, 4 oxygen. We have 2 carboxylic acid group and 1 carbon-carbon double bond. So we can make these structures. We have carbon, carbon, carbon. Let's suppose double bond is between first 2 carbon atoms. We have two carboxylic acid groups, so COH, COH. Rest of the number of hydrogen atoms, we have one hydrogen with this one, three hydrogens with this one. So overall the molecular formula is C5, as we have two carbons in COH, 3 here, H6, 3, 4, 5, 6, and there are 4 oxygen atoms. Now looking at the stereoisomerism, we can see that the carbon that is making double bond, it is attached with similar groups, so therefore it will not show cis trans. So we have one structure, this one. Let's shift the position of double bond. Now we have double bond between second and third carbon. COH is still in its original place. Now there is one hydrogen atom with this carbon, one with this, two with this. So molecular formula is same, and we can see the double bonded carbon, it is attached to two similar atoms, so cis trans is not possible. So now we have two isomeric compounds. Now let's change the position of this COH. For this one we can shift this COH to second carbon. Similarly for this one we can shift this COH to second carbon. So now structure will be like this. First COH is still on first carbon. Second COH is on second carbon. Double bond is still in its original position. In this compound we can see the double bonded carbon is attached to two different groups on one side. The double bonded carbon is also attached to two different groups on the second side. So therefore it will show cis as well as trans isomerism. So there are two possible isomers for this one. Now looking at this one, we can shift this COH to this carbon. So we have COH on first carbon, we have COH on second carbon. Double bond is in its position. Now we can see the double bonded carbon is attached to two different groups. One is CH2COH, one is just COH. This double bonded carbon is attached to two similar atoms. So cis trans is not possible for this one. So in total we have 1, 2, 3, 4, 5 up till now. Let's shift COH to third carbon. So if we have COH on first carbon and COH on third carbon, the position of double bond is between first two. Similarly, we can do it for this one. Now these two compounds are exactly similar. This is because the numbering will start from this end for the first one. So we have 5 carbons in total and double bond is on second carbon, and the numbering will start from this end for this one because the double bond is nearer to the end. So out of these we can only take one. Now looking at this structure, we can see the double bonded carbon is attached to two different groups on one side. The double bonded carbon is also attached to one hydrogen and one this group on the second side. So it will show cis, it will also show trans. So now we have 1, 2, 3, 4, 5, 6 and 7 in total. So 7 isomeric compounds are formed. Question 36. Compound X reacts with ethanoic acid in the presence of acid catalyst to produce compound shown. If this compound that is formed, what is the molecular formula of compound X? Now ethanoic acid, it can react with alcohol to form ester. If we look into this compound, we have a ketone, we have ester functional group. So if we break this ester from carbon-oxygen bond, the carbonyl part it comes from acid to make this ester, while the oxygen part it comes from alcohol. So it is 2 carbon acid, which is carboxylic acid CH3COOH, ethanoic acid. So the other part is alcohol, which is compound X. Let's write. We have CH3, C double bond O, CH2, CH2, OH. Molecular formula of this compound, we have 1, 2, 3, 4 carbons, 3, 4, 5, 6, 7, 8 hydrogens and 2 oxygens. So correct answer is D. Question 37. 2-bromopropane reacts with hot ethanolic sodium hydroxide. Now this is halogenalkane. Which substance is the major product in this reaction? And halogenalkane, whenever it is reacted with hot ethanolic sodium hydroxide, this one causes elimination. From one carbon we have bromine, which is replaced, and from the second carbon we have hydrogen that is removed. So hydrogen and bromine it is removed and alkene is formed. As to this reaction, we have bromopropane. On second carbon we have bromine. In total we have 3 carbon atoms. So 1, 2, 3. 2 is bromo and we have propane. In the presence of ethanolic sodium hydroxide, elimination takes place and from this carbon bromine is lost, while from adjacent carbon, which could be this one or this one, a hydrogen atom is removed and then a double bond forms. So we have double bond, if hydrogen is removed from here, and then we have CH3. So now we have 2 hydrogen atoms, one with this and CH3. Now if you are going to remove hydrogen from this carbon, then again same product is formed. It will be propene. So there is no change in product. It is still propene along with the removal of HBr. This HBr, it is actually removed in the form of sodium, bromide and water. So it means the product that is formed is propene. Answer is D. Question 38. Which compounds can be used to make Y in a single step reaction? Now let's see what is Y. In Y we have COOH. We have 2 carbon atoms attached to COOH. So this is carboxylic acid, CH3, CH2, COOH. So this one is propanoic acid. Let's see which one can be used to make this product in single step. First one is propane nitrile. In propane nitrile we have 3 carbon atoms. And as it is nitrile, so nitrogen is directly bonded to one of the carbon atoms. So we know propane nitrile, if it is refluxed in the presence of acid, for example you have dilute HCl, what happens, the carbon nitrogen bond it breaks and carboxylic acid is formed. So we have 3 carbon carboxylic acid which is formed along with the salt of nitrogen with the acid. So in this one hydrochloric acid was used, therefore salt is ammonium chloride. So we can make propanoic acid from this in single step. Second one is ethane nitrile. In ethane we have 2 carbon atoms in total. So it is CH3 C triple bond N. Now if we do the same for this one, it will make 2 carbon carboxylic acid instead of 3. So in a single step, propanoic acid cannot be formed. It is ethanoic acid that is formed. Third one is propyl ethanoate, which is ester. We have 2 carbon on one side and 3 carbons on the other side. If we hydrolyze this ester, or if we break the bonds, what will happen? Carbon oxygen bond, it always breaks. The part that contains C double bond O, it goes to acid, while the other part it becomes alcohol. So in the presence of water and acid, the product formed is 2 carbon carboxylic acid CH3COOH along with 3 carbon alcohol. So it is ethanoic acid that is formed, not propanoic acid. Last one is ethyl propanoate. Let's see, we have 3 carbons on one side as it is propanoate, and we have ethyl, so 2 carbons are on the other side. Again, breaking it in the presence of acid, we can make 3 carbon carboxylic acid and 2 carbon alcohol. So yes, propanoic acid can be formed with ethyl propanoate in single step. So as 1F4 is correct, therefore answer is B. Question 39. The monomer buta-1,3-diene can undergo addition polymerization in various ways. 2 of the polymers that can be made are called cis polybuta-1,3-diene and trans polybuta-1,3-diene. In these names, cis and trans have their usual meanings. What is the structure of the repeat unit of cis polybuta-1,3-diene? The product will also be cis. Let's draw structure of buta-1,3-diene. Buta means we have 4 carbons in total. One and 3-diene means we have a double bond on first carbon atom. We have a double bond on third carbon. So it is between 1 and 2 and 3 and 4. Let's add the number of hydrogen atoms. We have 2 with this one. 1, 1 and again 2. Now what happens when it polymerizes? So the pi bond is broken and 1 electron goes to the left side to make a new bond. 1 electron goes to this side to make a new bond. Similarly, when this pi bond is broken, 1 electron goes on left side, 1 electron goes to the right side. So in product, we have a double bond that is formed in the center, and these double bonds, they become single bonds. So now we have a new bond on left side, CH2, single bond CH, double bond in the center, then CH, single bond CH2, and a new bond is formed on the right side. So this should be the product. As we have cis as the repeat unit, so cis means that carbon atoms have same atoms on same side. So double bonded carbon, if hydrogen atoms are on same side, then it is cis. If hydrogen atoms are on the opposite side, then it is trans. So let's see, the structure should be like this, in which we have 2 single bonds at the ends and double bond in the center. So we have 2 double bonds at the end. This is incorrect. 2 single bonds at the end, 1 single bond, 1 double bond in the center. This one is also correct. This one is wrong. Let's see among these which is cis. So this is double bonded carbon. A hydrogen atom is present below. Another hydrogen atom is present above. So they are on opposite sides, so therefore this one is trans. In this one, we have this carbon that is making double bond. It has 1 hydrogen atom. This one also has a hydrogen atom. So as hydrogen atoms are on the same side, so this is cis. The answer should be C. Question 40. In the mass spectrum of a compound Z, the relative abundances of the M and M plus 1 peaks are in the ratio 13 to 1. So it means if M is 13, M plus 1 is 1. What is compound Z? We have to find out the compound. So let's see. We do have a formula to find out the number of carbon atoms present in the compound. We can use that formula. So it is N, which is the number of carbon atoms. It is equal to 100 divided by 1.1 into abundance of M plus 1 peak divided by abundance of M peak. We already know the ratio. M is 13, M plus 1 is 1. So we can put values. N is equal to 100 divided by 1.1 into 1 divided by 13. So number of carbon atoms, it comes equal to 6.99, which is rounded off to 7 carbons. Now let's see which compound given has 7 carbon atoms in total. First one is butyl butanoate. So it means we have 4 carbon on one side and 4 carbons on the other side, and this one is ester. So we have 4 carbons, 1, 2, 3, 4. And then we have butyl, so it means 4 carbons are on the other side. 1, 2, 3, 4. So in total we have 4 plus 4, 8 carbons. So this is wrong. It should be 7 carbons. B is hexane 3-one. In hexane we have 6 carbons. As it is a ketone with a double bond present on the third carbon, so we can draw structure. On third carbon we have a ketone. So in total we have 6 carbons. It should be 7. Third one is 2,2,3 trimethylhexane. So in total we have 6 carbons. Hexane 1, 2, 3, 4, 5, 6. On 2, 2 and 3 we have 3 methyl groups. So this is 2, 1 methyl group. Again on 2, second methyl group. Now on 3 we have another methyl group. So in total we have 6 and 3, 9 carbons. So this is also wrong. Last one is 3,3-dimethyl-pentane 1-ol. Let's draw its structure. We have pentane. Pentane means 5 carbons. One ol means on first carbon we have OH group. 3,3-dimethyl means that on third carbon we have 2 methyl groups. Now we can see 1, 2, 3, 4, 5, 6, 7. So in total we have 7 carbon atoms. So this could be the possible product. Thanks for watching. If this was useful, please do like, subscribe and share.